Hi, Sportster Paul here with SolidCAM, CAM, computer-aided manufacturing. It makes G-codes for your milling machine. We're messing around with the surfacing packages and the roughing packages. Those are all extra cost. You get two high-speed surface toolpaths, level and constant Z, as part of the base package, around $5,000, a little more, a little less, depends on your salesman. High-speed roughing, HSR, maybe a couple grand more, maybe more, a little less, depends on your discount. 3D iMachining, which is a roughing, but with adaptive tool paths, all swoopy, cool stuff. Then to get the full HSS, the surfacing, that's another $2,000. And then there's HSM, high-speed machining. That isn't meant to hog stuff out, it's meant to do, smooth stuff. So I'm trying to grapple, what can I get away with, the base package. We're going to be in the base package for the surface, but I might want to do radial stuff, which means at least one module extra. But let's go up and look at our SolidWorks. This is that oil tank thing I made for a Harley design I'm trying to do, a Sportster design. And what I did is I changed the part from when we last used it in another 3D episode. I put a 10-degree draft on it. Because of that, I had to reduce this fillet all the way around from 1/2 inch to 1/4 inch. Then the holes plunge and more fun stuff. I had this show half taped and SolidCAM went twang and stuff wasn't acting the same. So I got everything ready and hopefully I'll show you and make my points. Now, can I get away without any roughing, either HSR, high-speed roughing, or 3D iMachining? That would be $4,000 I could save, give or take. So I said, well, this part where the stock is like this, right? 8.5 by an 8.5 plate with 1.5 inches thick. So why machine all that extra aluminum, right? Why make chips? So I said, well, the first thing, let's just cut the perimeter out and leave the rest of the stock. Then to face it, well, I want it pretty. So rather than just face, same thing, why face that whole thing? Let's define it as a pocket. So this outside perimeter, and there's a little trick here in that I use the outside perimeter and then, well, here, we can go look at it. I was so put off by how complex things are until I use one of these complexities. And then I think, oh, everybody needs this. The geometry was just the outside perimeter, just a chain around the base of this thing, okay? But then the trick was modify geometry, all chains, each chain minus 0.03, and that's what pushed it out a little. And that means it's going to do, nice and clean and deck off that whole plateau. Matter of fact, we can show you. Let's get out of this. And let's turn off the tool paths. Well, the angle here doesn't matter, does it? Now, this is their great simulator. This is why you really got to love this thing. It's ready to go. Oh, by the way, I used 3/8 end mills instead of 1/4 inch for this. So 3/8 to do this perimeter, leave a nice big gap all the way around it. It's a tough operation, slotting. The fact that it breaks out here is actually a benefit. Oh, it's super fast because I'm getting ready to do the other stuff. Let's make it a little better. I decided to go from the inside out. You could go from the outside in. That's all easy stuff. And then when you go here and do the compare, you see it's perfect, green, within 1/1000th of an inch, plus or minus 1/1000th. So let's get this thing ready for the next time. So then I said, okay, high speeds, they're included in the base package is level and constant Z high-speed surfacing, HSS. So here I did it with high-speed surfacing. Matter of fact, while we're changing it, let's see high-speed surfacing sides. The geometry, let's just show you. I just went and picked. Now, here was the trick, right? And this is where the thing got confused. I must have tweaked this. You don't want it, if you generate tool paths now with these holes, it'll do retracts at every hole. It gets all confused. So my trick was to just take the slider bar here, go up above that, the holes all disappear, then generate, and I'm not going to do this because I don't know, things got tweaky on me. Generate the tool paths now. right? So then it just goes right past where those holes were, does it perfect. This is why you want CAM that works inside SolidWorks. And not something you bring an IGES file in, then you're suffering with, Mastercam's standalone Mastercam's CAD or standalone OneCNC or standalone Bobcat or standalone Visual Mill. That's why I'm looking at the 5 programs that work inside SolidWorks. You do the toolpaths, life is good. I could even show them to you. They show up like that. Sorry about this long retract. Like I say, I got burned once. We're running out of time here. Then you can just go back and look at your holes. Come back here. Life is good. Pretty much picking here, the tool, now it's a 1/4 inch ball mill, ball nose end mill. Levels, all that's automatic. The parameters, I went down here and said, I want within 1/1000th of an inch. It was, I think, 2. So that's like a step over of 30 thousandths because of the ball intersecting the sides. Tool control, don't think I did anything here. Like I say, I'm not going to touch this because that's how I burned myself on the first 3 takes of this. Somehow I started the part just from scratch, just like any software. Just start over from the beginning, and now it's acting a little better. So I'm going to close out of this. No. Do you want to exit? Yes, I do want to exit. I changed the name of it. That's what's going on. Let's see if it'll let me do that without clobbering anything. HSS space sides. Everything recording? Yeah, life's good. And now go save and exit. So I didn't touch the toolpaths. Now I want to show you this great simulator. We've got it sped all the way up. I noticed down here is the time that the machining time, right? So let's go here. I'm not sure it's right, to start from here instead of outside in. And so I'm sure all that can be adjusted. I just wanted to kind of get a feel for the difference between HSS and HSM. And the difference is one, you select surfaces. HSM, you select a model. It's high-speed machining, but the M makes you think of a model. Now watch. We'll go here. It's got to think. Now that's a pretty accurate surface, right? That means the sides, it's got a little chunkiness going on here. But that's amazing to me, right? Green everywhere, within 1/1000th of an inch of true. That's pretty impressive. That'll be a pretty beautiful part. So then I said, okay, now we got to suppress this because we don't want to do the same thing twice. So suppress that. Then I said, okay, let's use HSM, which is an extra cost module, but it has a lot of stuff in it. And so we're going to see if we can fix it now. You notice it's going in here. It's doing all this stuff. Plus, I think I should have mentioned. In HSS, I think I had a limit. No, we didn't. That's the nice thing about HSS. It just does the surfaces that you point to. HSM, I'm not too keen on. So let's do before this thing crashes. It hasn't been that unstable. I shouldn't make out like this thing is flaky. I'm sure it's me, operator error. Me doing stuff wrong. And you can see it's doing goofy stuff. It's drilling the holes. And I'm like, oh, well, I got to do the same trick. And you'll see the little wrinkle. You don't just move the bar and say recalculate, because it's taken the model when you made the geometry and said, pick the model. It doesn't really give you a choice. Pick the model. That's your geometry. Then it takes that and puts it in the SolidCAM data structure, right? So it's inside SolidCAM. So recalculating with that bar moved. But watch this. This is one thing that kind of upset me. It didn't upset me. It's like, oh, this isn't as accurate, right? It's got some yellow, so it's a little gougey. Don't ignore these big gouges. It's got a little blue. It's got a little excess here, right? Even though, if hopefully I'll be able to prove it, double click on it, HSM sides, in passes, same deal. I said 1/1000th, and of course that's only shallow areas, but no. So hopefully that's one aspect. Now, here's the thing. Okay, let's do what we did in that one show. It was so impressive with the surfaces. Doesn't work the same here. And I thought it was hosed. So you say recalculate the toolpaths. It exists. Yeah, we know. Just do it over. And see, it puts the same goofy stuff in. So the trick is go to geometry, select, and it wants a model, so just click that. Now it's taken the model as it is with the bar moved up and no holes and stored that in the data structure owned by SolidCAM. It's got its own thing to remember this model somehow. So now you say, okay, and if I did things right, all of this crap here and going down inside, that should disappear. Let's see. Yes, same thing. So, okay, 10 minutes in, there's going to be a quick show, but maybe worthwhile. And this is the other thing I'm not so keen. I kind of like surfaces. Carve this. I'll do this surface. I'll do that surface. I don't want to let it go nuts on a whole model. To me, that's like automatic, feature recognition, all these things that they claim are great that never work. So tool was same ball end mill. Levels, I had to do something. I had to make a boundary name, show. So otherwise it'll start hogging the whole stock. It'll see the stock and start doing all that extra stock on the outside. So I gave it this perimeter, the same perimeter. And then you had to go down here and say external. I want to keep the tool external. I can't remember if it was external or center. Passes, to keep it from going and doing the top, right? Even though the top's been faced, it's not smart enough. I had to add 1/1000 of an inch here, saying, oh no, limit this thing so it doesn't climb up on the face surface and then start rastering that ball and ruin our beautiful pattern we did with the pocketing. So just 1/1000 of an inch. That eliminated all the tool paths here. And I'm not sure that's the right way. I don't think I did it that way the first time, before I had some issues. I may have done it. Maybe you can do it with constraint boundaries where you define both the inside and the outside. You make 2 chains. So let's, we got a few minutes, right? Let's be high tone. So you see it's not quite as accurate. You see you got to deal a little trickiness. Oh, by the way, and now you can move back and it, you recalculate. It'll calculate based on the model as we selected it up here in geometry, not the way it looks, unlike surfaces. Let me think, what did I want to show us? We are going to go to passes. We're going to take this and say, go there. And now we should see it climb all over the surface of this thing. Think. Yeah. Okay, well, we don't want that. So let's see. I don't think I did it that way the first time. Constraint boundaries. Edit the boundary. Okay, so it's got chains. So let's see. It's got 1 chain. Let's see if we can put another chain here, right there. It's constant Z, tangent propagation. Do one more. It should go all the way around. Okay, we have issues. Sorry, folks. First off, let's make things look the way what we're trying to do. Next off, let's hide those tool paths. Then let's go back to draining the swamp, the boundary, right? So we're going to try to make between here and here so it stops doing all that. Not new. Let's edit the existing one. So there's the existing. Right? And it's 1 chain, but it looks like you can have multiples. Tangent propagation. I think if you do that, it's not smart enough. Now it is. I don't know why it needed that little extra push. Okay to accept. So that's kind of encouraging. I don't know if I should have started this one the same place I started this one. Well, let's hope for the best. Say, okay. Do a model, do a toolpath calculation, and see if it does it in between those boundaries. Yes, it actually climbs in a little. And that, I'm not sure is good. That might be a nice effect, right? To have that fillet actually climb over. That my buddy Dave, the guy who made that test part that's been tripping up all these CAM systems with automatic recognition, he sent me a great email about it's like you're an artist. And all these tool paths, the constant Z, the parallel, the radial, those are like the brushes you use to get a beautiful 3D surface. So he said, well, you got to have 3D, and it's kind of heart-stopping if you get full boat everything. It's kind of like Mastercam pricing. You'll be over $10,000. So that's why I'm exploring this. Maybe I assume you might be interested for these same reasons. So what did I want to show you? Oh, okay. What do we got? 15 minutes. This will be a nice snazzy show. Now, in the surfacing thing, at least when stuff is working right, like it did a few times, it would change the toolpaths and it would see these and it would affect the toolpaths. Here, because the model hasn't been reselected like this, yeah, we know it. See, because nothing's going to change. It's smart enough to say. So, it's nice. Now you know two ways. You can do another extra boundary curve, or you could do that 1,000th down limit and keep the tool from climbing around here. Meanwhile, so we got a good name. Let's get out of this. And this simulator, boy, it's worth its weight in gold. I can't see doing any 3D. We've suppressed the other one, and so now let's do our beautiful simulator. Take the compare function off. Say it's full speed, so it's going to jump around. You can kind of get an idea. And like I say, I assume there's a way. No, start at the base and move up. Of course, then you're running the side of the tool against the entire height of the loom. That's not a good way to do it. But, maybe a little one more roughing pass up at the top to carve in a little so the tool isn't plunging into full stock. Now let's see if we're still kind of unhappy with the accuracies. Yeah, see, not quite as good. Not quite as good. Might be a setting, right? But that's, to me, HSS means you're selecting surfaces. Pick, pick, pick. HSM means you're selecting the model and trying to limit and constrain and rein things in so it doesn't go crazy. In this kind of case where there's so much extra stock that's going to be broken off, that would be kind of crazy. So we can turn off compare. We can get out of here. It's interesting. It did this. See, the simulator is worth its weight in gold. The Mastercam and Bobcat simulator, I'm sorry. I don't know. I'm spoiled using this. That's why I'm trying to figure out if I can save a little money on the added modules. Do I need any of them? Do I need all of them? So what else did I want to show you? A lot. Obviously then, these holes are all broken out because I did the slant and that. So we're not going to go through and do the rest of the part. We're not going to go do the bottom of the part. Similar principles, right? HSM, HSR. As a matter of fact, the way this is designed, my design intent was to take a 1/2 inch end mill and you can just run it around here, centered on this or the edge, on the edge of the end mill on that, a ball nose 1/2 inch, or here, this is a 1/4 inch radius, and it comes out perfect. I've done it. Unfortunately, my Avid Benchtop Pro won't run a 1/2 inch end mill. The surface feet per minute at the tool gets too fast. So that's it. We're 18 minutes in. Quick show. Thought you've been interested. Hope you learned something. Sportster Paul here. I'm going to move from SolidCAM now. We're going to go back and look at Bobcat, go back and look at Visual Mill, maybe even touch on SolidWorks CAM by CAMWorks, because it does have a simulator similar to this. So more CAM coming. Stay tuned. Thanks for watching. Bye now.